Hello students, today we're going to continue talking about functions. Specifically, we're going to be talking about how to evaluate a function. Please take notes as you go and complete the survey that follows the video. So first, let's talk a little bit about function notation, as this may be new to some of you. When we evaluate functions, they are typically written in a specific type of notation. The notation looks like this, where we have the f, and then in parentheses we have the x. The way that we read this is f of x. It's the same idea as saying y equals, but instead we say f of x. That way we can evaluate. It's not always has to be f, it doesn't always have to be x. Some other examples that we have could be these: g of n, h of x, t of k, and so on and so forth. This notation essentially is taking the place of y, and it helps to see what values we need to use to evaluate the function. So the original function is going to be written as something like f of x equals and then some expression, and then we're going to indicate a specific value that we're going to want to find. So let's take a look at a couple of examples. So our first example here is f of x equals negative 4x plus 5. What we want to do is find f of negative 7. So what that means is we're going to find essentially the y value for when x is equal to negative 7. If you're taking a look at this, you can see the x is being replaced with negative 7 within our notation. So everywhere in our equation, we're going to do the exact same thing. We're going to replace it, so it says negative 4 times negative 7, and then we're going to add 5 to it. So as you see, the only thing we did was replace the x with negative 7. From here, we're now going to use order of operations. So we're going to multiply negative 4 times negative 7 to get a positive 28, and then add 28 plus 5 for a total of 33. So when I'm asking for f at negative 7, I want to identify what is our essential y value for where x is equal to negative 7. In this specific problem, it's 33. So that would be our answer. Let's take a look at another one. So in this problem here, we now have the problem x cubed plus x. So we want to find g at 2. So as again, you can see, g of x is now replaced with g of 2. So anywhere that we see an x, we're going to replace it with a 2 in our function. So this is what it's going to look like. It will now become 2 to the third power plus 2. So as you can see, there's x in 2 spaces here, so we need to put 2 in both of those spots. So we're substituting that right in for all those x's. So now once again, we're going to do order of operations. 2 to the third power is 8, and then we're going to combine 8 plus 2 to get 10. So g of 2 is equal to 10. Now, not only can we do this with just regular x's and so on, we can do it with other values. And here, pay attention to where the variable is. So we have h of n is equal to 2, and n plus 3 is now an exponent. So anywhere we see an n in this problem, we're going to put a negative 1 into that. Now watch how I write this down. I have h of negative 1 is equal to 2, and then it's going to be really tiny because this is an exponent, so it'll be negative 1 plus 3. So when I go to evaluate this, the key thing here is to make sure you're simplifying the exponent first. So negative 1 plus 3 is a positive 2, and then I can go ahead and apply the exponent. 2 squared is 4. Okay, so whenever you're given a problem where it's in the exponent, you need to simplify that like it's a grouping symbol, and then continue on with order of operations. Not only can we do things with numbers, but we can also do it with expressions. So we have d of g is equal to negative 2g plus 1. Now we're going to find d of 2n plus 1. So we're going to end up with a new expression. We're also going to follow the exact same process. Anywhere that you see a g, you need to replace it with 2n plus 1. So watch again how I write this. So I see a g is next to a negative 2. So I said, okay, negative 2, and then it's a really good idea to put parentheses around 2n plus 1. And then I have this other plus 1. So now I'm going to go through and simplify this. Again, I'm going to end up with a new expression. I'm going to distribute through with my negative 2. So I'll do negative 2 times 2, and negative 2 times 1, which is negative 4n minus 2. And then I'm going to simplify. My negative 2 and positive 1 can combine, and I get negative 4n minus 1. So once again, I ended up with n's because I substituted 2n plus 1 everywhere I saw a g. So there's no longer any g's in there. Just like in the other problems when we put a number in, there was no longer an x. So that is our answer there. Please keep in mind that we are replacing the variable in the parentheses with whatever the problem asks you to find in the new parentheses. We're then going to solve using order of operations. If there are variables, your answer will end in variables. Again, nothing is done to the left-hand side. It stays how it is. As you saw, I never divided by the number that was on the left-hand side because this represents function notation and it doesn't represent f times a number. If you have any questions, either put them in the survey or bring them to class tomorrow. Make sure you complete the survey that follows the video. See you tomorrow.